Hi, so this is a video on some basic algebra. If you're watching this, it will be after your first lesson, and this is sort of just to refresh your memory. If you've forgotten a few things from the lesson, that is totally fine. I'm going to be going over collecting like terms. I may do another 1 or 2 short videos like this, and you don't have to watch these. It's only useful if you need help on the homework, or you just want to be sure you know how to do this before coming into the next lesson. So with maths, you really do need to practice to get it right and to nail it. And once you've nailed it, you'll be able to just do it from then on, and then you can move on. You need to make sure your foundations are nice and strong before building further upon them. So I'm going to go over collecting like terms in this lesson. Before we go over some simple definitions, so a term is a variable in an expression. So let me just do this a bit nicer colour. So I'm going to write some terms over here. So we've got, in this box here, we've got terms. They are variables in an expression. So we'll go over what an expression is in a minute. I'm just going to write some terms. So 3a is a term. 3x is a term. 12xy is a term. 19x squared y cubed is a term. If you write this, 12x plus y equals 5, as a whole, this is not a term. So if you said 12x plus y is a term, you'd be wrong. Individually, 12x is a term, so we can say 12x is a term, y is a term, and you can sort of say 5 is a term, but there's sort of a grey area for stuff like that. So an expression is a collection of terms without a value. So I'll do another little circle over here for expressions. So if we said, we'll just write expressions in here. It may be useful to write notes on this, just so you can look back and remember. I think it's definitely worth writing notes on the main part of this lesson. This is just some definitions which may become useful. So an expression is a collection of terms without a value. So we know what terms are. They're like 5b is a term, and 5xy is a term. So an expression is a collection of terms. So we can say 5b plus 5xy is an expression. And it's important that expressions do not have a value. So if I said 5b plus 5xy equals 7, then this expression here has a value, therefore it's no longer an expression. So they don't have any equal signs. If you see an equal sign, it is not an expression. I'm going to do a few more examples. So you can say 2 to the x divided by y is an expression. You can say a squared plus b squared is an expression. You can say, you may not have seen this before, but sine of x is an expression. You wouldn't have seen this, but there's no equal sign. The one difference between an expression and an equation, so if we do an equation here, so equation is, it's an expression with a value. So say we had 3x, that's a poor x, 3x plus 2y is equal to 5. Well, this is an expression here, and this is its value. So an equation is an expression with a value. So I'll do a few more examples. 2 to the x equals 4 is an equation. 9xy squared plus 3 is 8 is an equation, because they all have values. You often hear of the term solve the equation, and that means you're just solving for this missing value, or missing values in the other cases. So those are some examples of equations and expressions and terms. there's one more term which may be useful, and that is coefficient. So the number before the letter in a variable. So say we have the term 5a, you can say 5 is the coefficient. So it just means the number before the variable. If a is the letter, 5a will be the coefficient. If we have 10b, 10 is the coefficient of b. If we have, for example, this one may catch you out, if you have 10xy, 10 is the coefficient of xy itself. So you can't say 10 is the coefficient of x, you have to say 10 is the coefficient of xy. So you could say in brackets letters in a variable. So coefficient is the number before the letter in a variable, basically. And we're now going to be going over collecting like terms. So this is what the basic lesson's on. We now know some terminology which we will be referring to. So collecting like terms, you may have also heard simplifying terms. So what does this mean? So you've got 5a plus 7b plus 3a. We want to simplify this down to a nicer form, and we can do that by collecting like terms. So what are like terms? This term here you may have heard before, collecting like terms. If you have 5a, 10b, 12ab, 7a, minus 3a, 11b squared. So the like terms are the letters which are the same. So on this one, we can see there's an a in this one, on the minus 3a, and there's a 5 there, and there's a 7 there. These are all like terms because they've got the same letters before the coefficient. If you look at 12ab, if it was just 12a, then 12a would be a like term. But because it's 12ab, this means something totally different. You can combine like terms. So I'm just going to go through this with some examples because I think that's the easiest way to learn it. Learning definitions usually don't help. They're useful, but to really understand something you need to do lots of practice and to see lots of examples. So 5a plus 7b plus 3a. We know the like terms are the coefficients between the same letters. So we can say 3a and 5a are like terms because they both have 1a. This basically means, I'm going to get rid of this, 5a means a plus a plus a plus a plus a. It's 5 lots of a. So you've got 5 times a, 1, 2, 3, 4, 5 a's, and then let's do some brackets here. And what I'm going to do, just to make this try pop out a bit more, so we've got in purple there, this is the pink purplish colour there, your 5 a's, and then let's do this different colour, and then in 3 a's here we've got a redder colour, and we can write the 3 a's next to it like this. There's 3 times a, so there's a plus a plus a. If you, and let's highlight that in red, so you've got your 3 a's there and your 5 a's there, and finally we've got our 7 b's, so we can write this on the end are 7 b's. So 1, 2, 3. We've got our 7 b's there. Nice. So you cannot see it for that colour. I'm going to go back and change that. Well, I'm just going to highlight it like this. So you can see these are the 7 B's. Well, how many A's are there altogether? If we count, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 lots of A's, so we can write here there is 8 A's. And how many B's are there? 1, 2, 3, 4, 5, 6, 7. Nothing's changed to the B's, so there are 7 B's. I went through this example slowly, showing how it works, but if you just look at the coefficient of A in this purple one, there's 5 there, and the coefficient of A on this red term, there's 3 there. That means if you add the coefficients, 5 plus 3, you get your 8A there. And with the 7B, there's nothing else to add to it, so it's just 7B. I'm going to walk through an example 2, a bit quicker this time, not writing all out, but I'm still going to show you. So what I usually do, well, it's easier to do this to learn, but once you've got used to it, you won't need to do this. If you highlight all the like terms, so like there's an x there, that's a like term, and there's a 12x there, so those are one pair of like terms, and I'll do it in orange. You've got your y's there, so these are your like terms, and then you can you can rewrite it like this. So you can say you've got your 10x, and then you've got your 12x there, and on this next part, in this orange colour, you've got your minus 5y, and you've got your 15y there. And now, because these are all of the same term, these are like terms, you can combine like terms. You can see the 10 and the 12, what does that make? 10 plus 12, that is 22x. And minus 5 plus 15, so that's the same thing as 15 minus 5, which is 15 minus 5 is 10. So we can say plus 10y. We combine the like terms. This minus 5 here and this 15 combines, this 10 and that 12 combines here. I'm going to go off one more example, two more examples, and then I've got one for you to do, and then you could go have a look at the worksheet and try do it again if you struggled, but if you understood it from the worksheet straight away, then you may not even need this video. So you've got your 10x squared there, and you've got your 5x here, and your 10x. It's a common mistake to think you can combine these two. So you can combine these two. This means x squared plus x squared dot dot dot. So you've got 10x squareds here, and then you've got your x, and you've got your 5x's there. You cannot combine this. You cannot combine an x squared with an x. They don't go together. They mean totally different things. So you can only combine when the algebraic variable is exactly the same. So let's do the same method we did before. Let's look for just x's. So we've got your 5x there, you've got your 10x there. Okay, now let's look for just x squareds. You've got your x squared there and your x squared there. And finally, the only ones remaining is y. So we can write your y there. Okay, now we can combine like terms. We can rewrite this like this. So you've got your 5x there, and you've got your 10x there. So this is a plus, it made 5x and a 10x. And now your x squareds, well, you've got 10x squared, and you've got your minus 5x squared, and on its own, loading it at the end, you've got your minus 2y. So we can rewrite this down. We can combine like terms. We see the 5x and the 10x, well, the 5 plus 10 combines to make a 15. So there's 15 lots of x, how many lots of x squared are there? Well, there's 10 lots of x squared, and you take away 5 lots of x squared, so this is just going to be 5x squared, because 10 minus 5 is 5. And lonely on the end, you have got your minus 2y. So this is your final simplified expression here. You've gone from this form here, and you've simplified it down and distilled it into a nice, simpler form. You've combined like terms. I hope this makes sense. And last of all, we've got a very challenging example. This example will show you sometimes you cannot combine like terms that easily, and there may be little tricks in there to catch you out. So we're going to start off doing the same method, and let's just start off with the y. How many y's are there? Well, look, there's no other singular y's, so we can't combine the y term with anything else. How many x's are there? Well, there's no other singular x's, so those two are going to be alone. What about yx squared? So we're starting here, and we've got yx squared, and we've got minus 25 lots of it. If you look over here, we've got x squared y. These two look similar, but they're not written in the same form. Here we've got x squared y, and on this place we've got yx squared. These two examples are exactly the same. If you write AB, A times B, it's the same as B times A. So for these two examples, we can say these are like terms. Yx squared is the same as x squared y, because you can just swap them around. This is just x squared times y. That's the same thing as y times x squared. So we can highlight this here. And finally, we have got our lone 5xy, which doesn't combine with anything else. So for this example, there's not much to write. We can see our minus 25, well, we can just change this to x squared y now, because they're basically the same thing, plus your 10 x squared y go together, and then I'm not going to bother changing the colours. On the end, it's just going to be 5yx plus x plus y. So basically everything else stays the same, apart from we combine these two. So minus 25 plus 10, that's the same thing as minus 15. So we can say minus 15 x squared y plus 5 yx plus x plus y, and that's our final answer. So here's an example for you to do. If you pause the video right now and have a go at this one, I'm not going to go through this one, but I am going to give you a hint if you couldn't do it after pausing the video. So pause the video now and have a go at that. So I hope you had a go. I'm now going to go over some like terms. So I'm not going to finish it off, I'm just going to give you a hint. So you've got your 10x squared there. Well, we look for the x squared. There's an x there, that's not an x squared. There's a y there. There's a 12x squared there, so we can highlight that. There's a minus 23xy, that's not right. There's a 20x squared y. We just want the x squared, so this is not an example. And we've got the 5xy there, so there's our x squared terms. We can do the same for x's. 8x, there's no x. There's an xy, but we just want the x alone, so there's no x's there. What about y? There's no singular y's. What about minus 23xy? We're looking for xy. This is x squared y, which is not the same thing, but the 5xy is. So those are our two like terms, and we can combine these and then write the rest on the end. We've got 10x squared plus 12x squared, and then in red, let me get my red colour. in red here, we've got a minus 23xy and our 5xy. And then on the end, we've got all our other terms which cannot be combined together because there's no like terms. So we can say we've got the minus 8x plus 11y plus 20x squared y. We can see these two terms here combine. So 10 plus 12, that's 22x squared. Minus 23 and 5, that is minus 8. This is meant to be a 5xy. I accidentally miswrote that. We all make mistakes. There's a y there. So that's 5xy and minus 23xy. This combines to make minus 18xy. And on the end, we've just got our minus 8x plus 11y plus 20x squared y. I said I wasn't going to finish it, but I did. That is your final simplified answer there. If you didn't get it, that is fine. Maybe watch through the video one more time, and then have a go at the worksheet. Hope you enjoyed.